Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Question 6, we have here a transverse wave. On the diagram we have displacement and time graph. On this figure, draw a wave which has half the amplitude and it has greater frequency. Okay, let me tell you what do you mean by frequency. Frequency means number of complete cycles, vibrations, oscillations produced, waves produced per second. Okay, on the x-axis here we have time. So if I, and you have here 0, so it's 1, for example, 2, 3, and 4. So we have here in 1 second we have half wave in 1 second. Okay, so we have half wave is produced in 1 second. If I would like to draw a wave which has half the amplitude and greater frequency, so in this space representing 1 second, I will draw now one complete wave in 1 second. So I am increasing the frequency will be greater. But we have another factor you should draw also, which is half the amplitude. So in this region, in this space, I will draw a new wave almost half the amplitude of the previous one. Okay, and it will be now one wave produced in 1 second, which means greater frequency. You may draw another one also. The second part, a train travels along steel rails. A person waiting at a station hears the sound of the train through the rails before he hears sound through air. Explain why this happened. You know that sound travels faster in solids than in gas. So you have to mention the reason here. Sound travels faster in steel, which is solid, than in air, which is gas. Is it clear? You can also remember that you can estimate the values for speed of sound in different media. In solids, it's a range, it could be 5,000 meters per second, 6,000, and so on. In liquids, it's a range of 1,500, like seawater, and in air, it's almost 330 meter per second or 350 meter per second. Is it clear? Can you tell me in the comments why sound waves, they travel faster in solids? Can you tell me in the comments, please? Okay, the speed of sound in rails here, 5,800 meter per second, and the frequency is given. Calculate the wave length. According to wave equation, the wave speed is equal to wavelength times frequency. So wavelength is equal to speed divided by frequency. You have to substitute, check units are consistent, and you have to find your final answer. The frequency here, 1100 hertz. So the final answer is 5.3 meters. Okay, guys. By the way, you should check your answer if your answer is realistic. How can you know it's realistic? Almost the wavelength of sound waves approximately it's higher than or greater than the wavelength of light. Wavelength of light waves, they are measured in micrometers, nanometers, and so on. But wavelength of sound waves, they are measured in meters. So 5.3 meters for sound waves wavelength, this is realistic. Is it clear? The last point, please don't use the triangle. This is not accepted as an answer. You have to write down equation. Equation is very important.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.